All right, let's talk about something we've all felt. You're working with MongoDB, and things just get slow. So what do? Well, today we're going to pull back the curtain on the single most powerful tool you have for fixing this, the query plan. Seriously, understanding this is like getting a superpower for turning those painfully slow queries into something that feels instantaneous.
Okay, so here's the game plan. We're going to start with the problem everyone faces, slow queries. Then we'll figure out what a query plan even is, how to read the thing, get the real story behind performance, and finally, lay out a clear path to make things fast again. Sound good? Let's go.
So, let's set the scene, and I bet this sounds familiar. Your app, it's just lagging. That feature that used to be snappy, now it's got that dreaded loading spinner, just spinning and spinning. And you know your users are noticing. The pressure's on, and you've got that gut feeling. It's the database. But where do you even start looking? How do you pinpoint the exact thing that's grinding everything to a halt?
And that leads to a really interesting question, right? When you tell MongoDB, hey, go get me this data, what does it actually do? It's not just wandering around aimlessly. No, it's smart. It actually comes up with a strategy, a little plan of attack to get that data in the most efficient way it knows how. And that plan is exactly what we need to understand to solve our speed problem.
So that strategy has a name, and it's called a query plan. You can literally think of it as the database's own personal GPS or roadmap. Before it even starts driving, it figures out the absolute best route to take to get to the data you requested.
So to put a finer point on it, a query plan is just the set of instructions MongoDB gives itself to fulfill your request. And that GPS analogy, it's perfect. The plan lays it all out. Is it going to take the super fast indexed highway to get there directly? Or is it going to get off the highway and check every single side street along the way? That's what we call a collection scan, and the plan tells us exactly which path it decided to take.
And here's the best part. MongoDB doesn't keep this a secret. It's not some black box. You can actually ask it, hey, show me your plan. And the way you do that is with one simple but incredibly powerful command, .explaining. You just tack it onto the end of your query.
Okay, so you've run .explain. Now what? You're looking at a bunch of text. Well, let's start decoding it. By default, when you just run .explain, you're in what's called queryPlanner mode. Think of this as Mongo telling you what it thinks the best plan is. It's our first big clue.
When you look at that output, you're going to see something called the winning plan. That's it. That's the one Mongo picked. And inside that plan, there's one field you absolutely have to find first. It's called the stage. This little word tells you everything. It's the how. How is MongoDB actually going about finding your documents?
And that brings us to the main event, really. The two stages you're going to see over and over. On one side, you have call scan. This is the villain of our story, the performance killer. It means Mongo is literally reading every single document in your collection. Think about that. It's like trying to find one sentence in a novel by reading it from page 1 all the way to the end. It's awful. On the other side, we have our hero, ixscan, index scan. This is what we want. This is like using the index at the back of the book to jump straight to the page you need. The difference in effort is just massive.
But hold on, knowing the plan is one thing. That's the theory. But how did it actually go when Mongo ran it? You know, did it hit traffic? Did it get lost? To get the real story, the play-by-play of what actually happened, we need to ask for something more. We need executionStats. So, .explain actually has a few different modes you can use. You've got queryPlanner, which we just saw. That's the what I'm planning to do mode. Then there's an advanced one for comparing plans. But for our purposes, for hunting down and fixing slow queries, the one you'll use 99% of the time is executionStats. This isn't the plan, this is the after-action report. It's the real data. Okay, so when you ask for those stats, you're going to get something that looks like this. And yeah, I know, it can look like a lot of noise at first. But don't worry, you can ignore most of it. There are really just a handful of numbers in here that tell you the entire story. Let's break them down.
So here are the big 4 you need to care about. First, execution success. Pretty straightforward. Did it work or not? Then, end returned. How many documents did you actually get back? ExecutionTimeMillis, that's your stopwatch. How long did the whole thing take? But then, there's the most important one. The one that's like a secret weapon for finding problems. It's total docs examined. This number tells you exactly how hard the database had to work to find your stuff.
So think about those last two numbers for a second. The number of documents you got back and the number of documents the database had to look at. What do you think is the most important comparison?
The most telling ratio to look for. It is this, right here. The relationship between total docs examined and n returned. When you see a chart that looks like this, sirens should be going off. This is a massive red flag. Look at that. To get just 5 documents back, the database had to sift through 50,000. That is an incredible amount of wasted work. We're asking it to do thousands of times more work than it should have to.
Okay, so we know how to diagnose the problem now. We see that call scan. We see that crazy high number for docs examined. We've found the source of the pain. So, how do we fix it? How do we go from that slow, painful call scan to a speedy IX scan? The answer, and I mean this almost every single time, is beautifully simple. You need an index. That's it. That's the magic trick that lets MongoDB stop scanning everything and start jumping directly to where it needs to go.
And this all boils down to a super simple 4-step playbook that you can use every time. Step 1. Identify the slow query and run .explain with executionStats. Step 2. Analyze the results. You're looking for 2 things, that call scan stage and that huge gap between docs examined and docs returned. Step 3. Index. Create an index on whatever field you're searching on. And the crucial last step, Step 4. Verify. Run .explain again and prove to yourself that the plan now uses IXScan and that your docs examined number has plummeted.
And I'm not kidding when I say the results can be just mind-blowing. We're not talking about a tiny 10% improvement here. It is completely normal to see a query become 10 times faster, 100 times faster, sometimes even more. This is easily one of the biggest bang for your buck changes you can make for your app's performance.
All right, so let's boil this all down. What are the key things to remember? 1. Use .explain executionStats to see what's really happening. 2. Hunt for call scan. That's your enemy. 3. Keep an eye on the total docs examined versus n returned. If that ratio is way off, you found a problem. And 4. The fix is almost always an index. That's what gets you to that beautiful, efficient IX scan.
So I'll leave you with this question. Now that you know exactly how to look, what's the slowest, most inefficient query that's hiding in your database right now? Think about it. Your next massive performance win could be just one .explain call away.
And that's a wrap on this explainer. I hope you found this useful. If you did, you know the drill. Go ahead and like, share, and subscribe so you don't miss the next one. Thanks for watching.